Okay, so we are going to be taking a look at graphing our first example, and I'm going to graph y is equal to 12 divided by x squared plus 12. There's a few things that I'm going to do. I'm going to first just write down horizontal asymptote, my vertical asymptotes. Well, that was not entirely right. My vertical asymptote. I'm going to figure out my y-intercept, and I'm going to figure out my x-intercept. Now, I'm just going to write these all down. I'm going to ask questions later as we go along to try to figure this out. So my horizontal asymptote, this is my first one. What I notice is my horizontal asymptote, when I'm trying to figure this out, my degree of top is 0, and the degree of bottom is equal to 2. So this implies, if I go over those cases, this implies that I have a horizontal asymptote of y is equal to 0. My vertical asymptote, now I'm going to do my work on the right-hand side. My vertical asymptote is when my denominator is equal to 0, or when the factors of my denominator is equal to 0. So very quickly, I'm just going to say, when is x squared plus 12 equal to 0? So you may just jump to the algebra, so x squared is equal to negative 12. Well, x squared is equal to negative 12. You may want to take the square root here, but it's not appropriate because you cannot take a square root of a negative number. Now let's go back to the original equation. Now I'm hoping that you're able to see, and you can't. There we are. I just left a little dent beside x squared. Since any number x, when you square it, is a positive number. So when is a positive number plus 12 equal to 0? Never. Since the positive number and 12 are both positive numbers, which are always greater than 0. So there is no vertical asymptote here. So I'm just going to put none. My y-intercept. My y-intercept is when I let x is equal to 0. So my y-intercept, if I let x is equal to 0, so I'm just going to say the f of 0. The f of 0 is going to be 12, 0 squared plus 12. Simplifying the numerator is 12 over 12, and there we have it. Now, I'm just going to make sure that I wrote down this question, and because it doesn't seem all that exciting to me so far. And indeed, I did write this down. So all the information that I really have is my horizontal asymptote. I'm going to do that in my blue marker here. And I draw it as a dotted line simply because it is not a part of the function and is imaginary. I'm going to delete all my previous hard work just to make this a little bit more clean to view at. So I'm going to take the shotgun approach here. And I don't know what my function looks like, but I do know that my y-intercept was 1, which begs a lot of questions. I guess I would say, well, what does the function look like when I have an x value of 1? What does the function look like when I have an x value of 2? What does the function look like when I have an x value of 4? What does the function look like when I have an x value of 8? And this is like a shotgun approach here. I'm just trying to throw paint at the wall and see which one sticks. So my y value when x is equal to 1 is 12 over 13. When my y value is 2, it's going to be 12 over 16. See, I told you this would not be very exciting. But I'm actually getting somewhere. And by the way, 12 over 16 is, I believe, 3/4. If you look at my dot, it looks like it's 7/10. Nobody really cares that much is going to look at this graph. However, I feel very comfortable that I got it on. I don't even need to do this. The f of 8, though, might be a little bit interesting. I'm just kidding. It won't be. But it's going to be 8 squared plus 12. So I'm just going to, I'm just estimating this now. So 8 squared is 64 divided by, or plus 12. So 64 plus 12, that's 76. Now, this number really doesn't mean that much other than it's pretty close to 0 and positive. And it has to follow asymptotic behavior. Similarly, I challenge you to press pause, and I like to call this throwing basically darts at your dartboard, and whenever they land, that's the picture that you're going to make. You're going to follow the rules of the asymptotes, though. And very similarly, you can easily calculate, and what we're going to have is we are going to have this beautifully symmetric graph. There. So my function does not have any vertical asymptotes. It's going to be totally smooth, and the highest point is going to be the y-intercept at 1. I got to make sure I have arrows at the end of my function. So that's what this first function looks like. So yeah, that was very unexciting. Let's maybe try to go to something a little bit more exciting. Let's pick another page here. I'm going to edit this. All right. I'm going to take my second function, and I'm hoping that it's a little bit more exciting than the previous one. The previous one did not have any vertical asymptotes. So again, I'm just going to write all of these down, my horizontal asymptote, my vertical asymptote, my y-intercept, which would be great if I had one, my x-intercept, that would be great. Now, anytime you can get points, these are really nice free information to get. So my next function is going to be y is equal to 2x plus 1, sorry, 2x plus 2 divided by x squared minus 1. Immediately, what I should probably do is factor this beast, right? And I notice in the numerator, I can factor out a 2. And in my denominator, it is a difference of squares, so I'm just going to factor it like that. All is good. What I'm able to see now is I have two non-permissible values, so x cannot be equal to -1 or +1. So these are going to be important. I'll try not to forget about these. Right, I'll just put a box around them. So here we have it. Now I'm going to start asking the hard questions. What is my horizontal asymptote? Well, I notice that the degree of the numerator is 1. The degree of the denominator is 2. So my horizontal asymptote is going to be y is equal to 0, because the degree of the numerator is less than the degree of the denominator. I'm going to draw a dotted line along where the line y is equal to 0 would be. My vertical asymptotes. Well, I notice that I have a factor of x plus 1, and they cancel each other out. So really, this graph behaves exactly like 2x minus 1, but x still can't be equal to plus or minus 1. Now, those are going to be important. However, it's really this function that I'm dealing with underneath. So my vertical asymptote, well, the factor where x is equal to, or x plus 1 was canceled out, that corresponded to the non-permissible value of -1. However, now I have a factor of x minus 1, so now I know that I have a vertical asymptote at x is equal to 1. So I'm just going to draw x is equal to 1, a vertical asymptote there. There we are. Hey, this is great. I have two guidelines. Pretty exciting now. We've hit the big leagues. So I'm just going to calculate my y-intercept. So my y-intercept, and by the way, my y-intercept is going to occur when x is equal to 0. So I'm going to just plug in x is equal to 0. And what I get -2, I believe. Well, negative, or 2 over 0 minus 1, that is -2. So, right there. That's awesome. We have it. We're good. Now, that is my y-intercept. Now, my x-intercept is going to be a little bit more challenging. I take a look at my reduced or my simplified fraction. So my x-intercept, I have to let y is equal to 0. So 0 is equal to 2 over x minus 1. So solving this equation is going to be very tough. Or you can ask yourself a simple question. The left-hand side is equal to 0. The right-hand side is only 0 in one specific case. When the numerator is equal to 0. When is 2 equal to 0? Never. So this actually has no x-intercepts, or no zeros, as I like to call them. That's my preferred word. Anyways, I think I'm ready to graph here. Now, this is going to have a shotgun approach to it, I think. And I'm just going to get rid of all of this word to sort of create space that, so that I can easily work on simple math without clogging the arteries of the viewing space. Very therapeutic, probably painful to watch at home, all this erasing. Okay. I believe my simplified function, I can't believe I got rid of it, but anyways, my simplified function was 2 over x minus 1, but x cannot be equal to -1 or 1. So what I'm going to do is the shotgun approach, and I'm sort of curious as what my graph is going to look like over here. There won't be any interruptions of a vertical asymptote over here. And also, I'm sort of curious as what my graph is not even there. I'm actually more curious all the way very close to the asymptote. What's my graph going to look like here? And there's really only one way. And that one way is to do this. I'm going to do the f of -5. The f of 0. The f of 1 negative. So I'm just going to plug in these values. The f of -5 is going to be 2 over -6, and that is going to be equal to -1/3, I believe. So we're all the way over here, but look that we're observing asymptotic behavior on the left-hand side. That is, my point is getting very close to 0. That makes a lot of sense, I think, to me anyways. If I plug in the f of 0, well, we already found this out, right? Because it's really my y-intercept. The f of 1 negative. Now, maybe I'm just going to put the alternative. This is what I mean. A number that is extremely close to 1, but on the left side. And what we have is we have 2 over 0.99 minus 1. But by the way, this is called the Sine Test, and it doesn't really matter. So the top is positive. The bottom is a number really close to 0. But what we know, 0.99 minus 1 is negative small. So 2 divided by something that's really small and negative is going to be a large negative number. So what I'm going to do is I'm just going to maybe put this dot down here. And this dot is a figurative dot. It doesn't actually exist, but I know that as I get really close to that vertical asymptote, that was a bad drawing, by the way. I'm just going to clean this up. Maybe pick this, and I'm going to make my asymptote a little bit lower. Keep on trucking, right? Goes all the way down. There we are. I think I'm ready to draw again. So the graph on the left-hand side, I have 3 dots, and I feel comfortable with 3 dots. And notice that very close to this asymptote, the vertical asymptote, right here, my function goes all the way down, pointing to negative infinity. And my function does not touch my asymptote. On the left-hand side, my function gets very, very close to the asymptote, but it also doesn't touch. So I draw 1/2. Similarly now, allow me to do the other half. So I'm just going to maybe try to find a nicer way to erase it. I wish I could do that. And then boom, and it would be erased. That would be so much easier. All right, so what am I going to do? I'm going to take this shotgun approach. I'm curious at what happens at the f of 1 positive. Now, really, that, like that, right? A number that is slightly larger than positive 1. So I'm interested to see, hey, what happens at the f of 2? Also, I'm going to pick a really far point, like what happens at the f of 6? You and I both know that this should go towards 0 at when f is 6. The y value should be very close to 0. But anyways, I'm to the f of 1 positive is going to be 1.01 minus 1. What we're able to see, it's going to be 2 divided by something that's positive but small. 2 divided by a small positive number is going to be positive, but it's positive large. Whoa. Now, again, that's a figurative point. Now, the f of 2. So when I put in the f of 2, what I get is 2 over 2 minus 1, and that is just going to be 2. So the f of 2 is 2. So I have a point 2, 2. 6. The f of 6. 6 is going to be, well, 2, and in the denominator, 6 minus 1 is 5. So I will have 0.6, and the y value is 2/5. But what we should see is a graph that behaves asymptotic behavior. There we have it. There's my graph. I know it was a lot of work, but this type of reasoning is so incredibly important.